Hello, in this video we will learn more about the uniform circular motion, centripetal acceleration. As we have already studied that the velocity of the object is changing continuously in direction and the object undergoes acceleration. So let's find the magnitude and the direction of this acceleration. Let r and r dash be the position vectors, means starting from C as shown in the figure, from C to P and C to P dash. And V and V dash are the velocities of the object as shown in figure A1. You know that the velocity at a point is along the tangent at that point in the direction of motion whenever the motion is curved. The velocity vectors V and V dash are as shown in the figure A1. They are tangent at the points P and P dash and perpendicular to the R and R dash. In figure A2, using the triangle law of vector addition, as the path is circular, so V is perpendicular to R and V dash is perpendicular to R dash. In figure A2, the vector V and V dash are displaced by making the same angle delta theta, and here we have used the triangle law of vector addition to find out the delta V. Therefore, delta V is perpendicular to delta R and average acceleration is along delta V, and the value of average acceleration will be delta V by delta t, the change in the velocity upon the total time interval. If we place delta V on the line that bisects the angle between R and R dash, it is seen that it is directed towards the center of the circle as shown, and the figure B shows the same quantities for smaller time interval, and delta V and hence the A is again directed towards the center. In figure C, delta t tends to 0, means instead of average acceleration, it will be the instantaneous acceleration and it is directed towards the center. Thus, we observe that the acceleration of an object in uniform circular motion is always directed towards the center of the circle. Now, let's find out the magnitude of this acceleration. The magnitude of acceleration, you know that the acceleration is rate of change of velocity. For a small interval, the magnitude of A will be limit delta t tends to 0, delta V magnitude divided by delta t. And the angle between position vectors R and R dash be delta theta. As the velocity vectors V and V dash are always perpendicular to the position vectors and the angle between them is also delta theta, therefore the triangle CPP dash formed by the position vectors and the triangle GHI formed by the velocity vectors are similar. Therefore, the ratio of the base length to the side length for one of the triangles is equal to that of the another triangle, or mathematically it will be delta V by V will be equals to delta R by R, or delta V will be equals to V into delta R by R. Therefore, the acceleration will become limit delta t tends to 0, V into delta R upon R delta t, but delta R by delta t is what? Velocity. So the average acceleration will be V by R V. So you got what? V square by R. And therefore the centripetal acceleration denoted by A with lower subscript c, AC will be equals to V square by R, where R is the radius of the circle and V is the velocity. Thus, you can say that the acceleration of an object moving with speed v in a circle of radius r has a magnitude v square by r, and it is always directed towards the center. That is why this acceleration is known as centripetal acceleration, because the Greek term which means center seeking. As v and r are constant, the magnitude of the centripetal acceleration is also constant, but its direction changes and it's always pointing towards the center of the circle. So, we can say that the centripetal acceleration is not a constant vector. Now, centripetal acceleration can be expressed in terms of angular speed. As we have calculated AC is equals to V square by R, and we know that V is equals to R omega. So by putting in this, what you got? R square omega square upon R. So ultimately AC will be equals to omega square R. And if we have to express it in the terms of frequency, you know that omega is equals to 2 pi nu. And by putting the value, you got 2 pi nu whole square into R. Now, a question based upon this uniform circular motion concept. A particle is present on the tip of the fan blade, 0.15 meter of radius, rotating at 20 revolutions per second. You have to find out its angular speed, linear speed. And is the acceleration vector a constant vector? What is its magnitude and direction? So, for this one, R is equals to 0.15 meter. Frequency is 20 revolutions per second. So, the omega, the angular speed will be 2 pi into frequency. That will be 40 pi radians per second. And the linear velocity, you know, V is equals to omega R. So by putting the value of omega and r, it will be 18.84 meter per second. And the direction of velocity will be along the tangent of the circle at every point. Now, we know that the acceleration in the circular motion is always pointed towards the center of the circle and it changes. So acceleration is not a constant vector. And the value of acceleration is omega square r. So by putting the value of omega and r, you got it 2368.8 meter per second square. Another question from your NCERT. An insect trapped in a circular groove of radius 12 centimeter moves along the groove steadily and completes 7 revolutions in 100 seconds. You have to find out the angular speed and linear speed of the motion. And is the acceleration vector a constant vector and what is its magnitude? So here omega is equals to 2 pi nu or 2 pi by t. So it will be 2 pi into 7 by 100 means 0.44 radians per second. And the linear speed will be equals to omega into r. So by putting it, you got 5.3 centimeter per second. And I have explained in the last question also that it is not a constant vector. And the value of magnitude of acceleration will be omega square r. By putting it, you got 2.3 centimeter per second square. That ends your kinematics unit. In the next video, we will start the next unit. Thank you.